Okay, so we are going to go over the additional Punnett square practice from the incomplete dominance that we did in class yesterday and today. It is due tonight for periods 1, 2, and 3, and due tomorrow for periods 4, 5, and 6. But I won't actually be posting this until tomorrow for periods 4, 5, and 6, so it'll be due for the day you watch this, basically. Alright, so as we went over in class, we did talk about incomplete dominance. And we did the first cross for roses, and that was if big R is red, big W is white, and RW is pink, we're going to predict the phenotype ratio. So we knew the cross, so we have to do the phenotype cross because that's the first thing it asks us to do. We need to do a Punnett square, which we did, and then we wrote the phenotypic ratio right here. Okay, so we have our cross, our Punnett square, and our ratio. Boom, done. All right, so let's look at B. And we're using the same R's, W's, and RW's. Okay, so our P1 cross for this one, for a white plant and a pink plant. So we're going to have big W, and big R, big W. Make your Punnett square, monstrous in this case. Put your parent 1 on the top, parent 2 on the side. Okay, W is going to be after R's. So put your W's down all the way to the right. It's not that it's less dominant, it's just that it's going to go in alphabetical order. Slide your R's over and add your W's here. Okay, what is our phenotypic ratio for this one? Well, this one is going to be pink, 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 white, white. So that will be 2 to 2, pink to white. Okay, let's look at number C, letter C. We're going to cross a red plant again, so big R, with the pink plant, which is RW. I forgot to underline that, sorry. You can put a box too, either which way. Let's make our Punnett square. Big R, big W for parent 2. Drop your R's in, slide your R's across, slide your W's across, and voila! We have our Punnett square completed and our ratio. So this one's going to be red, this one's going to be red. This one has the mixture, so it's pink and pink. So we have 2 to 2 again. Red to pink, sorry. Red is the first one listed, so we need to go red to pink. Okay? Hopefully that makes sense. It honestly doesn't matter for that one. You can do pink to red too. Alright, P1 cross of 2 pink plants. So let's do RW with RW. There we go. RW. So that will get us, drop our R's down, drop our W's down, bring our R's across. That's a W, not an R. One day I will be able to read the alphabet again. W and W. So, this time, our phenotypic ratio is, we have 1 red, we have 2 pinks, and 1 white. Okay? And you can write that red to pink to white. Okay, so hopefully that makes sense. You can read my scribbling writing. Sorry about that. And that's our plants for number 1. That's the end of number 1. Moving on, we shall look at number 2. And this really should be level 2. I'm not quite sure. I think I mistakenly put level 3 there when it should have been level 2 right above number 1. I think I just put it in the wrong spot. So, not a level 3. Alright, so in some cats, the gene for tail length shows incomplete dominance. Cats with long tails and those with no tails are homozygous for their respective alleles. Cats with one long tail allele and one no tail allele have short tails. Predict the phenotypic ratio of a cross between all 4 of these. If we have big L is a long tail, big N is a no tail, and LN is a short tail. So our P1 cross for number 1 or 2A, we have to cross a long tail and a no tail. So we're going to cross our long tail, LL is long tail, with a no tail. Okay, make your Punnett square. Maybe make some room so you can write on top of it. Ay. I think I do better with binder paper, guys. This is crazy. Alright, big L, big L, big N, big N. Fix the corner. Might be a little OCD-ish, it appears. There we go. So, L's are going to come before N's, so drop your L's on the left. Slide your N's over. And our phenotypic ratio is, well, we have short tail, short tail, short tail, short tail, 4 to 0, short tail. Okay. Sorry, my writing is really sloppy tonight. Okay, P1 cross. For B, we're going to do a long tail. So LL with a short tail. So that's LN. Punnett square. Let's see if I can make this one a little bit nicer. So our parent 1 goes on top. Parent 2 goes on the side. Drop your L's down. Slide your L across. Slide your N across. And there we go. Let's do our phenotypic ratio. Okay, so we have long tail, short tail, short tail. So we're 2 to 2, long to short. Tails. Sorry, you can write tail on there. You don't need to, though. Alright, so that's that one. Let's go on to C. I just have to move it above the keyboard. It doesn't work so well if I don't do that. Okay, so our P1 cross here, short tail is LN with a no tail, NN. Okay, so let's make our Punnett square first. LN on top, NN on the side, and drop your L's down, drop your N's down, bring your N's across. Okay, so we have short tail, no tail, short tail, no tail. Okay, so 2 to 2. Again, 2 of each. Short tail to no tail. And no tail looks like one word. My apologies. Alright, let's cross 2 short tails. So that's LN times LN. Okay, LN, LN. Bring your L's down, bring your N's down. Slide your L's across, slide your N's across. And we get long tail, short tail, no tail. So this time our ratio is going to be different. We have 1 long tail, 2 short tails, 1 no tail. Long to short to no tail. Okay? Excellent. Number 3. We did number 3 in class. If you were in first period, you did not have the updated multiple alleles part. So I've given you the alleles, I've given you the phenotypes and the genotypes for each phenotype. Notice that there are, for type A and B, there is a homozygous version where it's IB and IA for type A, but there is also a heterozygous version where you have IA and you have the O allele. The O allele is your little I. So the same for A and B, okay? Type AB is also heterozygous. It is big I, big A, big I, big B. Remember, these are in the superscripts, so they're not down low, and make sure they're not even with the I's. And then our homozygous recessive is our type O. So it was a brief overview for first period mostly, because you guys are the ones that I did not have this ready for because I forgot. I'm sorry. Please forgive me. Okay. So we did number 3 in class. Let's look at number 4. So number 4 says we have a man with type O blood. So that means our P1 cross with type O blood, he's going to be little I, little I. That's the only blood type that he could possibly be, okay? Or only genotype, rather. He marries a woman with type AB blood. Well, look at type AB, find the genotype. There's only one genotype for that one as well. So down here, you're going to copy that. Big I, big A, big I, big B, okay? What will be the possible genotypes and phenotypes of their children? So first of all, we put parent 1 on the top here, parent 2 on the side. Sorry, Rocket and Riley are running. I apologize. Little i's go down to the right. And we can, that is one of the only ones that you don't have to really check the rest of them because little i's are the recessive. It's the only recessive allele, so they can always go straight to the right. This time you slide your big I, big A over, and your IB. Okay. So our possible genotypes for our children of this cross is, well, we have this genotype, that's the same, this genotype, and that's the same as that one. So we have I, A, I, or I, A, oopsie, B, sorry. That was silly. You can tell it's been a long day. IB, little I, okay? So, what is the phenotype for IA, little I? Go back up here and look. Find your genotype, IA, little I. The phenotype is type A. Okay, so come back here, we write A, type A, okay? Big I, big B, little I. Do the same thing again, go up here. Find that phenotype, or genotype, which is right here. It's the heterozygous form of type B. Come back here, type B. So the two possible blood types that the babies could have would be A or B. Okay? Let's look at number 5 in a minute. This one is actually going to be a level 4 question. I just didn't have it in the right spot. So I'm going to come back to that in a second. Let's do 6 first, since that's the level 3. Okay? So, what is the probability that a couple whose blood types are A, B, and O will have a type A child? Okay? So, if one parent is AB, then we go I, A, I, B, right? Because our P1 cross is I, A, I, B crossed with type O would be little I, little I. And then little I goes there. Does that make sense? I'm hoping it does. If not, please come talk to me. In this case, the AB blood is dominant over O. So I'm going to drop my A on the left. And I'm going to drop my B on the left. Okay? Slide your little I's over. Okay? So what is the chance, percent chance, that a child will have type A given these parents? Well, we have a 25% chance in this box, none in that, and a 25% chance in this box, and none in that. So 25% plus 25% is going to give you a 50% chance that you will have a type A baby if you have one parent being AB blood and the other one being O. Okay. Let's go back to 6. 5. Sorry, 5. Okay. Okay. So a type B woman whose mother was type O. So let's take this piece by piece. Type O is, so we start with the mom. Type O is I, little I, okay? Which means that our type B woman can only get an O allele from her mom because you have to get one from each of your parents. So her genotype must be heterozygous. So she must have gotten her B allele from her dad, her O allele from her mom. So our P1 cross is going to be IBI crossed with a type O man is little I, little I. Okay? So let's put this on our parent one here. IB little I here. Little I here. Bring your IB down because it's the only dominant allele we have. Everything else is recessive. Okay, slide your little i's over. Little I, little I. So our genotypes is what we have from this. We have two different genotypes. We have IBI and II. Everybody hopefully can see that by now. IBI, heterozygous for type B, and little I, little I. So we know that this is type B because that's exactly what mom is. Mom here is IBI. And we know that little I from right here is O. So those are our two types of blood types. Okay? So moving on to number 7. A type A woman whose father was type B. So if she's type A and dad was type B, he had to have been heterozygous. So he must be IB little I, which means she didn't get the B allele because she's type A. She must have gotten an O allele. So we go IA little I. So mom must have been A blood and given her the IA allele, and she got the O allele from dad. She marries a type B man whose mother was type A. Just like over here, mom must have been IA heterozygous little I because he's type B. So she must have had an O allele to give him. Okay, hopefully this is making sense. So our P1 cross shows the woman is IA little I, as we just figured out, and the husband, the dad, not necessarily the husband, hopefully, but never know, is IB little I. Okay? Alright, so mom is this, dad is that. Mom goes here on top because she is listed first. Dad goes here on the side because he was listed second. Okay. Now, here's where we have to be careful because they might not necessarily be in order. Take into account what you have on the side. So IA is the most dominant one. Not dominant, but it will come first in our heterozygous ones as well. So that one can easily go at the very front in this case. Little I is the most recessive, so it goes there. Slide your big I, big B's in. Okay, and look at there. Oopsie, that's not right. What did I just do? I just did the whole thing like it was the same. This is actually little i's. There we go. I'm tired, guys. Sorry. Genotypes. Well, we have IAIB, IBO, IAO, and II, which is O. So we are going to do the one that has the both dominant alleles first. So IA, IB. Then we will do our heterozygous ones that have the O alleles because that's the recessive one. Do your A first because it goes in alphabetical order. So IA little I, and then IB little I, followed by little I little I. Okay. The resulting phenotypes. Well, this one here will be AB blood, and you can always go back and see what our chart tells us, and you would be provided a chart on any test or quiz. Okay. This one is type A and O, so the A is going to be expressed. This one, B, is going to be expressed, and lastly, O. Okay, so 25% chance of any of those combinations of blood types. Kind of crazy. Last one. A couple has a child with type A blood. If one parent is type O, little I, what are the possible genotypes of the other parent? Okay, so put your little i's in. Okay, so we know that the child will be heterozygous, which means that baby could be, well, all of them are going to be IAI, little I, okay? But you only have to have 25% chance of it to happen. So these don't have to be the same. So we know we want to have at least one A, okay? Which means that parent 2 will have to be either homozygous for type A. If parent is homozygous, then this would also be IA, okay? But she could also be heterozygous, right? Or the second parent could be heterozygous, because that will still give you this chance here. But parent 2 could also be AB, because it still gives you the chances of having IA. So we can put IAIB will definitely could result in an IAO child. Oh, I should have done that one first. IA first, because homozygous goes first. IB. And then, lastly, IA little I. So there's 3 different genotypes that the other parent could have had. See how when we get tired, how many more mistakes we make? It's kind of crazy. All right. So that's that. Hopefully that answers everybody's questions and you are understanding how to do the Punnett squares for blood types. If you do have any questions though, please email me, come see me during pause, or ask in class. Have a great evening, guys.